Okay, this is section 8.3 in your textbook. We're looking at surface area and volume of prisms and pyramids. We have a lot of definitions here on the side, and we need to make sure we are aware of, okay? So we should know these. These are review. Alex, go ahead and read them.
Surface area, the number of square units needed to cover the surface of a three-dimensional object. Volume, the amount of space that an object occupies, measured in cubic units. Pyramid, a polyhedron whose base is a polygon and whose faces are triangles that meet at a common vertex. And lateral faces, the faces of a prism or pyramid that are not bases.
Okay, good. So surface area, just generally speaking, is the outside area, correct? So it's like all of the material that would be involved in a box, all of that outside area material. Volume is the amount of the inside, right? All of that inside space. Okay, surface area is expressed in how many dimensions? Yeah, 2 dimensions, right? It's area. And volume is expressed in, Matthew, how many? 3 dimensions, right? Because it's 3-dimensional. It's the inside area, okay, or inside volume. So the pyramid is a polyhedron whose base is a polygon whose faces and triangles that meet at a common vertex. It's a kind of a lot to take in, but basically what they're saying is that there's a base and there's triangles that fold up and they meet at the same point, okay? So if we think of a square-based prism, square, we know there's 4 sides. So square-based prisms, all of those triangles would fold up and meet at a point. And that's what we see here in this example. Okay? This is a square-based prism. The base is square, and there's 4 triangles that all fold up to a single point in the middle. Any questions about those 3? Okay, finally, lateral faces. They're the faces of a prism or pyramid that are not bases. So in other words, the sides. Okay, they're not the top, they're not the base, they're the side faces. Okay, so here we see what a lateral face is here. We're going to look at just the first part of this investigate. A square-based prism and its net are shown. So there's the pyramid, and there's the net. This looks a little, kind of a little strange. They're trying to show it in 3D. Typically, though, that point should be right in the middle. It looks like it's off to the left, but really it's right in the middle of that pyramid. They're just trying to show all the sides. What is the shape of the base, Justin?
Shape of the base is a square.
Good, square. Tim, write a formula for its area. Yeah.
I think it's just a square.
Sorry?
The whole thing.
Yeah.
Oh, so you have to find the area of the square, which would be length times width.
Okay.
Then you would also have to find the area of the triangle, which is base times height divided by 2.
Actually, sorry. I think it's just for the base. Yeah, so just length times width for now, yeah. So would we write length times width for a square?
No.
Justin?
Can't you do s squared?
Yeah, side length squared. Or we could just do width squared, right? So it just depends what we call the side, right? Let's call it, let's just call it W for width. So the surface area, or sorry, the area for the base, area of the base is equal to W squared. You guys all understand that? I don't have to put L because I know L is the same as W. So it's just W times W, W squared. What is the shape of each lateral face? So each side face, Nicholas, what's the shape of them?
Isosceles triangles.
Okay, good. Triangles, yeah. More specifically, isosceles triangles, okay. I know you did, yeah. I'm just repeating you. I'm just repeating what you said. Write a formula for the area of one of the lateral faces.
Base times height divided by 2.
Okay, good. 8, area of the triangle. In this case now, Nicholas, what would we call the base?
Side length of the square.
Right, and what variable did I use?
W.
Right, so it would be more like W times height divided by 2. Agreed?
Yeah.
Okay. Finally, write an expression for the surface area of the pyramid. Stephen.
Sorry?
We're gonna write an expression for the whole pyramid now.
You have to do the area of the one square, and the surface area of the one square, and the surface area of one triangle times 3.
Right.
Or 4, sorry.
Okay, so our surface area of our pyramid is equal to the area of our base plus the area of our 3 triangles. So we have the area of our base, w squared, plus 4 times w times height divided by 2. All right, any questions? All right, if we were developing a formula for a hexagon-based pyramid, how would it change? Yep.
It would all be the same except instead of multiplying by 4 by the triangle
Yep.
surface area, it would be times 6.
Excellent. Hexagon would be times 6. Octagon would be times 8. This number here. Okay? Any questions? All right, we're going to go straight to the example here. Surface area of a pyramid. A modern example of a pyramid can be found at the Louvre in Paris, France. The glass square-based pyramid was built as an entrance to the famous museum. Calculate the surface area of the pyramid, including the base area. So it tells us, this is very important, it says it's a square-based pyramid. And then it gives us one side length. Okay? And that's all we need. It also gives us the height of the triangle. Do you guys see that? See the right angle there? So if you were to make a net of this pyramid, you would see that this is the height. So that's all we need. We need just the base width and the height of the triangle. We should be able to figure it out. So here's our base, 35 times 35, or w squared, plus 4 times the area of the triangle. 4 times 1/2 base is 35, and height is 27.88 as given. Okay, we calculate 3171, making sure to know the units, which are meters squared. Any questions? All right, I think that one was fairly simple. Go a little more complex. We're going to look at volume now of a pyramid. So we just found surface area of a pyramid. We found surface area for a square-based pyramid, also for an octagon-based pyramid, as well as a hexagon, right? Just change that number that we multiply the triangle areas by. All right, so we're looking for the volume of the pyramid-shaped container to the nearest cubic centimeter. So the volume of a pyramid is 1/3 the area of the base times the height. So area of a triangle, 1/2 base times height. Volume of a pyramid, 1/3 base times height. Any questions about that? All right, so that's the first formula you guys need to remember. You need to know that. Okay? So first we need to determine the height of the pyramid. We don't know the height. We're given the hypotenuse here. So we need to find the height. And now when we're dealing in volume, we're not talking about the height of the triangle. We're talking about the height of the pyramid. So from the base right up to the vertex. We're not talking about that hypotenuse of the triangle or the side length. We're talking about the height of the triangle. Straight up, straight down. Okay, did you guys understand the difference? Okay, very good. So then, here's our height. Can you guys see this in this triangle? I'll zoom in here. Do you see that? How they give the hypotenuse here, the side length. This is 4 because it's halfway into the base, and this height here is what we need to solve for. So we create a triangle that looks like this. Everyone understand how we go from this 3D shape to this 2D shape? Any questions? All right. Knowing that, we can use our Pythagorean theorem and solve for h. H is one of the sides, so it stays on the left side, and we need to move this over and solve for h, which is 9.2. Any questions? Okay, once we have the height, we can calculate the volume quite easily because we know the area of the base because it's a square-based prism, so it's just 8 squared. So our volume is equal to 196. Yep. Oh, sorry. Thank you. Finally, the second part says express the capacity in liters. If we have our volume in 196 centimeters cubed, here's the equation you need to go from cubic centimeters to milliliters. 1 cubic centimeter is equal to 1 milliliter. That is very important. Therefore, if we have 196 cubic centimeters, we know we have 196 milliliters, or 0.196 liters. Everyone know how to go from milliliters to liters? Move the decimal place 3 spaces, correct? Okay, Christian. Okay. We'll do the last example after lunch.